Tharindu Wickramasooriya, and before we start off comparing programming languages used in game development, I'll be taking you through this narration about the various programming language features that are of importance when considering the language perspectives on which a game's performance depends. First place of consideration generally for the game developer goes to the floating point values. A 3D game requires a variety of mathematical computation, and it is by no means an easy task to make sure that distances between you and your enemy are correctly calculated to the point, or calculate accurately the time that you need to control the situation until reinforcements arrive when you're under attack, or map the textures on the walls and guns that you see in the game without overlapping them so that you see the wall and the gun together. Now, all of these things are handled by the amount of precision that you get through floating point values, and a language has to provide extensive and strict support for floating point values if you are considering it for serious game development. And next we talk about another play in the development arena, which is dynamic memory allocation. Dynamic memory allocation is of vital importance in a game because a game itself is dynamic in its aspects. Suppose you are developing a game such as Crisis, where a lot of things, even minute details such as birds or maybe rivers, leaves, sunlight, flow in and out of the game in a rapid succession. Take bullet shells firing off your gun for an instance. You fire off, the shells come out of the gun, they splatter on your screen and they go off. These things have to be dynamically mapped in and out of memory in a very efficient way in order to maintain order within a game without making it crash. Thus, a language has to be very strict in its support for dynamic memory allocation. Apart from the two key points we have discussed in terms of a language's support in game development, it would be a complete nonentity if we don't express views on any of the superstars of games on top, which is graphics. All the cool graphics you come across in various game engines such as Dunia in Far Cry 2, CryEngine 2 by Crytek, or various other high-end game development engines for the PC and Xbox platforms, all of them highly rely on the language of development to provide them with both safe and secure access to graphics devices such as graphics accelerators or commonly known as GPUs. Thus, a language has to be very rich in its support for fast access to devices in order to feel the raw power of the device and in turn provide maximum graphics experience to the user in a fast and swiftly detailed manner. Next comes garbage collection. Imagine yourself racing across a beautiful country towards the finish line. You come across various things in the game such as trees, tires on the road, dust, weather effects, maples you crush away, other components you compete with. Where are all these stored? In memory, of course. And what would happen if all these objects are not deleted when it's absolutely unnecessary to keep them in memory any longer? You would of course run out of memory halfway through your race, and now we wouldn't want that, would we? Therefore we come to the concept of garbage collection, where unnecessary and no longer used objects or data are deleted off memory. This comes built in with the language used mostly for game development today, and we should consider this strictly when we're choosing a language to develop our own game with a very rich environment. Next comes referencing methods. Would you like it if your gun fires a second after you press the fire button, or if the plane doesn't take a turn when you mean it? Why would this phenomenon happen even if you have used all the perfect design patterns to implement your game engine? The glitch would of course be in the language you use for game development, and the wanted criminal in the aspects of the language would be how fast the methods are referenced from the actual time they were called during a key press or a button click. Most languages today all provide almost similarly fast access to game methods on event fires, but it is nonetheless a key factor that contributes to a game's performance and is completely independent of the hardware or the implementation of the game itself. Although trying to figure out these details as a newbie might be a bit complex for you, it's always worth trying to find this out, since it can make your life easier as a game developer someday. Now we have data types, value types. The data types and the value types allowed in a language controls the whole process of your game implementation. If you don't have the necessary data type at your disposal, where would your ammo go? Or your weapons for that matter? How would you have implemented all the weather effects, the shaders that expose the beauty of an environment and whatnot in the game? Earlier languages provided only a few data types for the programmer to deal with, and this often led to frustration because you never had the flexibility you needed when you had to develop your own game. And today's games were yesterday's dream that would never have come true unless for the advancements of technology and also the ability to introduce custom data types, which brings us to explain the final key point we have to discuss in our narration: object orientation. It has not only provided the entertainment industry the ability to create sophisticated games, but it also gave you the flexibility to edit it at leisure without spending much time to understand the code you have developed, and it made it easier for the programmer to maintain his code as easily as lovable. Languages today support for a variety of object orientation methods such as data hiding, inheritance, polymorphism, and many other features that allow the programmer to build flexible and rich games in a matter of hours using application frameworks and libraries that are available at their disposal. And now we will be comparing two languages and two application frameworks that use these languages in order to identify which framework would do better at game development. The frameworks that we have for our discussion are the XNA 3.0 framework from Microsoft and the JMonkey framework from the open source community. XNA is based on C# and JMonkey is based on Java.